Let's talk about how to graph absolute value functions when we have more than one transformation occurring at the same time. Okay, we're going to graph by finding the vertex and one point on each side. So our first problem is negative absolute value of x plus 4 plus 3. Okay, now we previously talked about how to find the vertex. Remember, we use the inverse of the h value as x and the k value as our y value. So in this case, our vertex would be located at negative 4, positive 3. Okay, and again, we already know what h and k do. If h is negative 4 and k is positive 3, that means h moved left 4 units and k moved moved up 3 units. We haven't really talked about what A does. So let's talk about this formula. Okay, the general transformation formula is A times the absolute value of x minus h plus k. Given an A value, if your A value is greater than 1, and actually let's make that if the absolute value of A is greater than 1, then it is a vertical stretch, meaning it's going to make your graph more narrow. If the absolute value of A is between 0 and 1, then we have a vertical shrink or compression, okay? Meaning it's going to make it short and fat. Now, if your A is negative, okay, that has nothing to do with stretch or compression. Okay, I want you to understand a negative A value has nothing to do with a stretch or compression. A negative A value will simply cause a reflection over the x-axis. Okay, now that is a lot to keep in mind. Your A value does perform quite a bit of functions. H, we already discussed, as horizontal transformations. It moves your function left or right. And K is a vertical transformation or vertical shift up or down. This is what you have to keep in mind when you're talking about transformations. Now, if you look at A, we already discussed the vertex, what H and K do. This time, our A value is negative 1. So what does that mean? First of all, 1, absolute value of A, absolute value of negative 1 is positive 1, does nothing in terms of of a stretch or a shrink. However, because it is negative, this is telling us that it's going to cause a reflection. Okay, and if we think about a reflection, if our parent function opens upwards, a reflection is going to open down. That's all a reflection is. Okay, so moving on, let's go ahead and find additional points to graph. Negative 4 over 3 means we are reflecting down. I'm going to graph my coordinate, negative 4, positive 3. And I know I'm going to picture it, it's going to open downwards. Okay, remember we need to find 1 point on the left, 1 point on the right. So left of negative 4, I'm just going to pick negative 6, and I'm going to substitute it in for x. So negative absolute value negative 6 plus 4 plus 3. Simplify, negative 6 plus 4 is negative 2 plus 3. Absolute value of negative 2 is positive 2. And notice that my negative on the outside stays on the outside all the way. Okay, plus 3, and now I have a new function. Negative 2 plus 3 is going to give me positive 1. So my coordinate point is at negative 6, positive 1. Graph that. And then pick a point to the right side. So to the right of negative 4, I'm going to go with 0. Negative absolute value of 0 plus 4 plus 3, right? And you guys can enter this into your calculator if you find the absolute value sign. There are shortcuts to this. You don't necessarily have to do this all by hand. So absolute value of 0 plus 4 is just 4 plus 3. Negative 4 plus 3 gives me negative 1, making my coordinate point at 0, negative 1. Okay, so I plot my point as 0, negative 1. And then remember, you can do reflections. So if I reflect this point here, I am 2 to the left, so I'm going to go 2 to the right. This is where my coordinate point would be. And then I'm going to reflect this point. How many am I away? 1, 2, 3, 4. Go 4 to the right or left. 1, 2, 3, 4. This is a reflection of my coordinate point. Now I have several points, enough to guide me to draw my function. Remember, take up all of your graph. There's nothing wrong with doing so. Draw your arrows at the ends. And we have our function. So for domain, there's no restrictions. It's going to continue growing left and right. So our domain goes from negative infinity to infinity. Now, for the range, where does our graph start? In this case, remember, range is read bottom to top. It's coming in from negative infinity, right? It's growing, and it's going to end at positive 3. So bottom to top, we write it out as negative infinity up to 3. Don't include infinity, bracket around 3. Okay. All right, let's go ahead and try B. G of x equals 4 times the absolute value of x minus 5 minus 2. Let's start by identifying transformations. A is positive 4. Remember, if the absolute value of A is greater than 1, it is a vertical stretch. So I know this is going to be, or this is causing a vertical stretch. H, what's our H value? Well, it says minus 5, which means H is positive 5, meaning it's going to shift right. And K, you can see, is negative 2, which means it is going to shift down 2 units. Okay, based on our H and K values, our vertex is located at 5, negative 2. So I'm going to plot my point at 5, negative 2. And then again, find 2 points, substitute, and draw extra points. For my first point, I'm going to use 3. So 4 times the absolute value of 3 minus 5 minus 2. Simplify inside the absolute value gives us negative 2. Absolute value of negative 2 is positive 2, and my absolute value now becomes parentheses because I'm multiplying. 4 times 2 is 8. 8 minus 2 is 6, meaning we have a point at 3, 6. Okay, so 3, 6, plot my point. Second point to the right, I'm going to use 8 this time. So 4 times the absolute value of 8 minus 5 minus 2. Okay, simplify. 8 minus 5 gives us 3. So absolute value of 3 minus 2. Absolute value of 3 is just 3. 4 times 3 is 12, and 12 minus 2 gives us 10. So our second point is at 8, 10. So 8, 10, here's my point. Now I'm going to use reflection to draw out 2 extra points so that my graph is as straight as can be, right? And if I use my first point from the vertex, 2 to the left means I'm going to go 2 to the right. Here's my reflection. And my second point from the vertex is 3 units away, so I'm going to go 3 to the left. Here's my reflection. You can see pretty straight. Connect my points. Remember, use a straight edge if you have it. And there is our function. Don't forget your arrows at the ends. Okay. Domain, absolute value, there's no restrictions. You can see it's going to continue growing from left to right. So we go from negative infinity to positive infinity. And for the range, identify where does your function start. In this case, it starts at negative 2 and continues to grow infinitely. So for the range from negative 2 to infinity, our vertex is at negative 2, so bracket, parentheses around positive infinity. Okay, all right, now if you look at C, C does have something that is a little bit different, okay? And I'm just going to talk about this transformation really quickly. C has a B value. Now, we usually don't use B values, which is why I didn't list it up here, but It is there, okay? And this is a 1 over b value. Actually, it's not just b. It's 1 over b. What this will do is the same as a. It functions the same as a, except it provides, I'm going to try to squeeze it in here. It provides a horizontal shrink or stretch, okay? Same as a. So if the b value is greater than 1, it's a stretch. If the b value is less than 1 or 0, it is a horizontal shrink, okay? And what you have to realize is that this is always going to be the reciprocal. It's not what's listed in the function, it is the reciprocal, okay? As for reflection, if it's negative b, it will be a reflection over the y-axis. Okay, and we're not going to go too much into it. I'm just listing your b values so that you can list the transformations for c. For example, our b value, right, we're listed as negative 1/2. We use the reciprocal of b, so b is actually 2, negative 2, okay, which means that we have a horizontal stretch and we have a reflection over the y-axis. Okay, now in terms of graphing, you graph it the same way, find a point to the left and to the right of the vertex, nothing else changes. Our h value is -3, which means it's going to move left, and our k value is +1, which means it's going to move up 1. Okay, everything else remains the same. Our vertex is our starting point. You're going to pick a point to the left of the vertex and a point to the right of the vertex, substitute and graph, okay? So that's as much as I'm going to do for you. Find the additional points, find the domain and range, and then do D and E and come back and check your work when you're all done. All right, so this is what you should have for C. As you can see, I substituted the point -5 and I got -5, 2, and +1 and I got 1, 3. Again, if you chose different points, that's okay. Just make sure to reflect them after you have plotted them to help you graph your function. So this is what it should look like, going from -infinity to +infinity, and the range from +1 included to +infinity. For D, you had all 4 transformations occurring. You had an A value of -1, which causes a reflection over the x-axis. You had a B value of 1/3, which causes a horizontal shrink. You have an H value of +1, which moves it right, and then K was 0, so no transformation there. Vertex is located at 1, 0. I use the points -1 and +2. Okay, so here's my points. Your points may be different once again, right? But you can see that I plotted my points and then I reflected them over to the opposite side in order to draw my function. Domain from -infinity to infinity. Range comes up from -infinity to 0 included. Okay, D, you had an A, H, and K. Now, A was -1/5, so it does 2 functions there. We have a reflection over the x-axis and a vertical shrink. H is -6, so it moves left, and K is +4, so it moves up. Now, for my points, because I did have a fractional A value, I found values that would give me whole numbers. If your values gave you decimal numbers, that is completely okay, right? Just make sure that you are graphing them as accurately or using as much precision as you can according to your decimal values. I used -11 and got 3, and then I used 4 and got 2, okay? Now, in this case, the only one I could reflect was my -11/3 to the opposite end. 4/2 I could not reflect because it would be off of the graph, but you can see it pretty much lines up. And again, my graph covers the entire coordinate plane here. It's not just a little segment, it's the entire coordinate plane. Domain goes from negative infinity to positive infinity, and range goes from negative infinity up to positive 4.